you guys. If you're following along in McGraw-Hill, we are in chapter 3, getting towards the end of this chapter. We're doing a lot with division. Right now, we're doing a lesson where we're focused on what it means when we have a remainder. It's really important to understand that because when we divide a number that has a remainder, we need to talk about what does that remainder mean? Is it a part of the answer? Where is it going? What is it doing? So I'm going to do a couple short little examples before we get to the one when we interpret a remainder when it's related to problem solving when we have a real life scenario, okay? So let's say we have the problem 21 divided by 4. I know it's going to be a remainder because this is not a fact family, but let's go ahead and divide and go through our steps. 4 cannot go into 2, so I need to say what is 4 go, how many times does 4 go into 21? So I'm going to list my facts over here. I know that 4 times 5 is 20, and 4 times 6 is 24. 24 is too big. I can only go up to 21. So my answer is going to be 5. So I place the 5 above the 1. Make sure it's placed right here. Not above the 2 because we said 4 goes into 21 5 times. And then we multiply. 5 times 4 is 20. Then we subtract. 21 minus 20 is 1. And then bring down, but I don't have anything to bring down, so I'm done. And so our answer is 5 remainder 1. Now, what does that mean? I really want to talk about what that remainder means. Remember when we divide, we're dividing anything, we're dividing a number, or you can be dividing cupcakes or pencils or books, or dividing how many people can sit at a table. But the important thing is that when we divide, you're trying to figure out how many equal groups I can have, and then there might be a remainder left over. What does this remainder 1 actually mean? Well, let's go ahead and relate it to models. So remember our 21, if this was written out like this, 21 divided by 4 equals 5 remainder 1. The 21 is the number that was being broken up, right? 21 was being divided. So if I draw my blocks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then another 10 to create 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1. So here's my dividend, 21. I want to divide it into 4 equal groups. That was the divisor. 4 equal groups. Hint, hint, equal. Whatever blocks I put in here, all of these have to have the same amount until I can't do it evenly anymore, and that's when we talk about what's left over. So I'm going to do 2 at a time. So 2 here, which means I have to put 2 in each of the groups to continue making equal groups. So far so good. Each one was able to evenly have 2. Let's do 2 again. 2, 2, 2, 2. Okay, so far so good. Each group has evenly 4. But now look how many we have left. 1, 2, 3, 4, 5. I have 5 blocks, or 5 models, or 5 ones, but I only have 4 groups. So I'm going to do 1, 1, 1, 1, 1, 1, 1, 1, and look at that. I have 1 outside of my equal groups. That's why 21 divided by 4 is an even 5 equal groups with 1 left over. So an algorithm, this is the answer, that 4 can fit into the number 21 5 times, right? With 1 left over, okay? Now I'm going to relate it to a real world problem so that we can interpret a remainder in a real life situation, which makes it a lot more fun and I think make a little bit more sense. Let's go ahead and look at an example here. Let's say I have 174 students and they're about to go to the cafeteria to eat their lunch. Every student needs to sit, and each table can only fit 8 students at a time. So 1, 2, 3, 4, 5, 6, 7, 8. So one table can fit 8 students, and I have 174 students who need to sit at a table. So the question might be, how many tables are needed? And you guys, can I tell you that these are the type of real life situations and problems that we deal with every day. We do math every day, all the time, when you might not even realize you're doing it. So if I was going to set up the cafeteria so that every student had a place to sit down for lunch, and I know I have 174 students and only 8 students can fit on one table, I need to do the math to figure out, well, how many tables will I need to ensure everybody has a seat? So let's go ahead and do the problem. So it's going to be 174, because those are the things I'm dividing. I know that sounds funny because we're talking about students, but if you think about it, the 174 students are going to be divided into equal groups, right? Because they all need to sit at their own table with 8 evenly at each table. If there's an even amount, we'll find out. So the problem is 174 students divided by 8 students. Now, why is it divided by 8? Well, those are the numbers that were given to us in this problem solving. So it's 174 students divided into 8. Why is it 8? Because we need groups of 8, because only 8 students can fit at one table at a time. So we're going to go ahead and go through the steps of dividing. 8 cannot go into 1, so I need to see how many times 8 can go into 17. Well, 8 times 2 is 16, and 8 times 3 is 24, which is way too high. So the most it can go in is twice. And 2 times 8 is 16. Then I subtract. 17 minus 16 is 1, and then I bring down the 4. 8 goes into 14 how many times? Well, 8 times 3 is 24, way too high. 8 times 2 is 16, still too high. So I'm going to say only once. 1 times 8 is 8. Then I subtract, I borrow, and then we subtract. So 14 minus 8. So 14, 13, 12, 11, 10, 9, 8, 7, 6. Okay, and then do I have another number to bring down? I don't. So this is 21, remainder 6. So I want you to look at that answer and think about what we were originally working with. We were originally talking about students being broke up into groups of 8, and this answer tells us how many tables, okay? So 174 students broken up into groups of 8 means I need at least 21 tables, right? But what does the remainder mean? The remainder is the part of this lesson that we need to make sure we understand how to do. The remainder is going to be interpreted. So if we need 21 tables to fit evenly groups of 8, right? Because only 8 students can fit at a table at a time. What about the remainder 6? The remainder 6 are 6 other students. Are those students going to sit anywhere? Do they still need a table to sit at? They do. So even though I don't have another full group of 8 students, there's still going to be another table, but it'll only have 6 students sitting there. So in reality, how many tables are needed? Yes, I need the even 21 tables that each have 8, but I still need a table for my remainder of 6 students. So the answer is 22 tables. So again, don't forget that this remainder directly relates to the scenario you are working with. We were trying to get even groups of 8 students, but I ended up with a remainder of 6. I didn't have another 2 students to make another even table. So do these students need a table? Yes, they do. So that's why instead of just the 21, we actually need 22 tables so that everyone has a seat. All right, you guys, I hope that helps you understand what we do when we interpret the remainder and relate it to real life examples.